Okay, welcome back. We had said last time we were going to go over how the periodic table is organized in these questions. So how are the elements organized on the periodic table? Well, the modern periodic table is organized by increasing atomic number. Remember, Mendeleev organized it by increasing atomic mass, but we don't really do that today. The vertical columns, vertical means going up and down, they're called groups or families, and they're called groups or families because the elements in the families or the group have the same number of valence electrons. So that's the answer to the third question. What do the vertical columns tell us about an atom? It tells us the number of valence electrons, which also identifies its chemical properties, which leads us right here to the fourth question. It says elements in the same family or group have similar properties, and they have similar properties because they share that same number of valence electrons with everybody else in the family. And the horizontal rows going across are called periods. Now, as we said, the modern atomic model is the electron cloud. The Bohr model accurately represents how the electrons are on energy levels, the different energy levels, and it identifies the number of electrons on each energy level. The only thing it doesn't have is that 3D swirling cloud effect. But it's much easier to look at and understand. So pretty much universally in chemistry, people use the Bohr model. And the Bohr model shows the electrons and the energy levels of an atom. And of course, we know the nucleus contains the protons and the neutrons. And each energy level contains a certain number of electrons. So we take a look at the periodic table. Before we said there was period 1, and period 1 corresponds to the first energy level. Period 2 corresponds to an atom having 2 energy levels, like when we looked at beryllium. Period 3 has 3 energy levels. Period 4, all of these elements have 4 energy levels. Period 5, all these elements have 5 energy levels. Period 6, all these elements have 6 energy levels, including these down here that should be stuck in this place up here, where it says 57 to 70, here they are. And here's the 7th energy level, and then 89 to 102 fit in there. And the reason why they're cut out and stuck down here, we said, was so that it would fit better on the page. It's a highly technical reason. Now, when we look at this first energy level, there's 2 electrons that can be on the first energy level. The electron for hydrogen, and then helium has 2 electrons because it has 2 protons and the atom's neutral. So that's the end of the first energy level when there's 2 electrons. It's filled up. That's all it can hold. Now, the second period, or the second energy level, has 8 electrons on it. There's an electron for lithium, and then beryllium would have 2 more, and all the way up to 3, 4, 5, 6, 7, 8 more electrons. So on this second period, or second energy level, there's a place for a total of 8 electrons. Now, we're at neon, which is element 10, and there are 10 electrons that would correspond to neon's 10 positive protons. There's just 2 of them on this first energy level, and then the other 8 are on the second energy level. Now, on the third energy level, there's going to be a need for 8 more electrons. For these electrons that would correspond to these 8 elements, all the way up to argon, which has a total of 18 electrons, so it would have 8 more. And these are all going to be valence electrons because they're going to be on the outside energy level. So there's 8 electrons can fit on this third period or third energy level. And when we get done, that's all that we don't need anymore. Now, I made this periodic table, and this looks a little bit different than the periodic table usually does. Usually we have a box with the elements and the atomic mass here at the bottom. I stuck the Bohr models in this one because I want you guys to see how this corresponds. So helium has 1 valence electron, so that it balances out with its 1 positive proton. This 1 valence electron is represented by this 1 dot in the dot diagram. And then the next element with an atomic number of 2 is helium. Well, helium is going to need 2 electrons to balance out these 2 protons. because it has an atomic number of 2. These 2 valence electrons are represented by those 2 dots. And those are all the elements that live on the first period. So the first period, or first energy level, never has more than 2 electrons on it. And when we get down here to the elements on the second period, they all have the electrons filled on their first energy level. So I filled in all the 2s, because that first energy level is filled. Their second energy level electrons. So you can't have an inner energy level that's not full like this. Okay. So now lithium has an atomic number of 3, so it should have 3 electrons. So on its second energy level, it gets 1 more. 2 plus 1 is 3. And it has 1 now on its outer energy level. It's 1 valence electron, and there's its 1 dot in the dot diagram. Lithium has 1 more proton, so it should get 1 more electron. So it has 2. And now it has a total of 4 electrons, which balance out as 4 protons. And boron has 5 protons, and atomic number of 5. 2 plus 3 is 5. It has 1 more electron than beryllium did. It has 3 valence electrons, and that's why it has 3 dots in this diagram. Carbon should have 1 more electron than boron did, because it has 1 more proton. And sure enough, it has 4 valence electrons. Plus the 2 from the inner energy level is 6, and it has 6 protons, so this atom is neutral. 4 valence electrons are represented by the 4 dots. Nitrogen has 1 more valence electron, so it has 5. It has 2 plus 5 is 7 electrons total. Atomic number is 7, so it has 7 protons. The 5 valence electrons are represented by these 5 dots. Oxygen has 6 valence electrons. It has 1 more than the nitrogen. That gives it a total of 8 electrons. The 2 that live on the inner energy level plus these 6 is 8. That matches up with the 8 protons. The 6 valence electrons match the 6 dots in the dot diagram. Fluorine has 1 more valence electron than oxygen did, so it has a total of 9. It matches its 9 protons. 7 valence electrons match the 7 dots. Neon has 1 more electron. Outer energy level is full now. Okay, we have 2 plus 8 is 10. And there's no more elements on this second period, so that's all the electrons the maximum number that will ever live on this second energy level. So the first energy level is filled when we're at 2, and then the second energy level is filled when they're at 8. And that brings us on down to this third energy level. Well, the third energy level starts off being filled with the electrons from just like this. So there's the 2 and the 8. So I filled them all in because they all had the first and second energy level filled. And sodium should have 11 valence electrons, or 11 electrons total. There's only 8 here, and this is full. So this next electron goes on the third energy level, which is where sodium lives, is on period 3, with all these elements have 3 energy levels. So it has 1 valence electron, 1 dot, and dot diagram, total of 11 electrons. Magnesium has 1 more proton, so it should have 1 more electron. It has a total of 12 electrons. 2 plus 8 plus 2 is 12. These 2 dots represent these 2 valence electrons. Aluminum should have 1 more electron than magnesium did. 2 plus 8 is 10, plus 3 is 13. That balances out as 13 protons. 3 dots represent this 3 valence electrons. Silicon should have 1 more electron, so it does. It has 4. It's a total of 14 electrons now. 4 valence electrons are represented by the 4 dots. Phosphorus should have 1 more electron. It does. And it has a total of 15 electrons. 2 plus 8 plus 5 is 15. It has 15 negatives. It has an atomic number of 15, so it's 15 positive protons. 5 valence electrons are represented by the 5 dots. Oxygen has 1 more proton, so it should have 1 more electron. We have 5, now we have 6. These outer energy level electrons are balanced. The 6 valence electrons here are represented by these 6 dots in the dot diagram. And chlorine has one more electron than sulfur did. It has 7 valence electrons down, a total of 17 electrons. It matches up with its atomic number of 17, 7 dots in its dot diagram. Argon has one more electron than chlorine did, because it has one more proton. It has a total of 18 now. 2 plus 8 is 10, plus 8 is 18, so we have 18 negative, 18 positive, 8 dots in the dot diagram represent those 8 valence electrons. Now you can see why people use these dot diagrams, because they don't want to have to draw these Bohr models all the time. They just say there's 7 valence electrons, so we'll put 7 dots. There's 5 valence electrons, and we'll put 5 dots. We're going to look at one more period and see how that goes. Now, the elements on period 4 already have their energy levels filled up. The first 3 are filled up because they kind of take up where argon left off. So we have the 2, 8, 8, just like the argon. That gives us 18 electrons. It has 19 protons, and it has 4 energy levels. So there's a place for, so the third period, the third energy level is filled with our 8. That's it. There's no more. And we go to this 4th energy level, and we're going to add in the 1 electron on the 4th energy level. So the potassium now has 19 electrons, 19 negatives balanced with 19 positives. This 1 balanced electron is represented by that 1 dot. And look, everything in this first family has 1 balanced electron, and they all have 1 dot. So the dots make things simple. Calcium has 1 more balanced electron than sodium did. So there's 2 balanced electrons now, a total of 20 electrons. So we have a neutral atom. 2 dots represent the 2 balanced electrons. Now these transition elements, we skip over it in middle school. And the reason why we skip over them is their electrons go on an inner energy level. They go back here on the 3rd energy level. And we're dealing with the 4th energy level right now. See, they're back here, they're underneath. And we already have 2 out here for the calcium. So the 3 for galenium, the 3 valence electrons, are on top of these 10. They're underneath. That's why we say they transition from being like a 2 to being like a 3, because their electrons are tucked in on this inner energy level. You don't really need to completely understand that, but as a matter of fact, if you don't, when you take chemistry in high school, you deal with it then. The point is, we now have a total of 31 electrons. 2 plus 8 is 10, plus 8 is 18, plus 3 is 11, plus 10 is 31. The atom is neutral. Now, uranium starts off with the 3rd energy level filled, and the 10 from the transition elements stuck up under here underneath. And it gets 4 valence electrons right here on this outside energy level. And that gives it a total of 32 electrons. The 4 valence electrons are represented by the 4 dots. That's why it's in family 4. Everybody in family 4 has 4 dots. And the argon, arsenic, it has 1 more valence electron than germanium did. It has 5 valence electrons, 5 dots. We have a total of 33 electrons on this atom. And selenium has 1 more, because it has 1 more proton. We have a total of 34 valence electrons. Bromine has 1 more. Okay. It has a total of 35 negative electrons, 7 valence electrons here, represented by the 7 dots. And this krypton has 8 valence electrons. Now, this 4th energy level is filled. We have the 2 here, plus the 10 there, and then 6 more for these 6. So if you look at this end one, we have 2 plus 6 is 8, like the krypton. And then we have 8 in the 10, 8 in the 10, and then 2. So this is how it goes. It goes, this is full, we go over here to 8, and this is full, we get 8 more, and this is full, we have 2 more, and we have our 10 transition elements. They're kind of on the back burner here, their electrons are underneath. And then we have the 6 more that we put in over here that changed our balance. It was 3, 4, 5, 6, 7, 8. And we're at the end of the 4th period. We're going to pick up here next time, and we're going to look at how you guys are going to try and make some Bohr models.